little bit of this before. And what you guys did back when we worked with graphing of trig functions is that there was a question on the test that I gave you, or on the quiz, excuse me, that I gave you. I gave you the parent graph and its shift, and you guys wrote the function. Well, what's going to be different today is that you're only going to get the shift. You won't be able to see the parent.
But then we make the parent?
No, you're going to write the function off of it. But before I do that, I want to revisit how do you graph trig. This is a really good refresher here. I want to graph y equals -2 plus 3 sine of 4x. I want to go through all the steps, including writing the parent and the shift, and re-explain what all the values mean. The better off we are to start with that, what we finish up here in 4.5 or 14.5 makes a lot more sense. That's why I need you to, not be crazy. Now, when we did sine, cosine, this is only going to be sines and cosines, just so you know. We always had them in the form y equals a sine b x minus h plus k. Where a was helping you to figure out the what? Amplitude. So we would list out our a, our b, our h, and our k, where the absolute value of your a giving you your amplitude.
Your period.
How do you find period with sines and cosines? Very good.
Yeah,
2 pi over b. So the period.
Pi over b, but that's
Correct. And then your h and k were horizontal and vertical shifts. So when we're looking at this where it says y equals -2 plus 3 sine 4x, what's your a, b, h, and k?
3.
Which means that there's no horizontal shift, but there's a vertical shift of
2 down.
2 down. Good. Now, when you're dealing with sine, your sine curves, whether your a value is positive or the a value is negative, where did your sine curve always start in parent? 0. Sine always starts at 0, then where did it go?
Up or down, depending on your a.
So that it went to the a. It went to whatever your a value was. 0, opposite a, 0. Cosine started at an a or started at the opposite.
Then on a is 0, opposite a.
So we remember this. Sine starts at 0, then to a max or a min. Does that make sense?
Yes.
It's either maximum or minimum.
Yes.
Because your a would be positive a would be maximum, lower, negative a lower. Whereas the cosine starts at a max min, and then it goes on to a 0. Okay?
Yeah.
Just a little refresher just so you remember that. So let's plot this one out. Remember when we plotted, we would start by trying to draw a straight line. What was the first thing we would put on here? The period. So in this case here, our period would be 2 pi over 4, which is?
Pi over 2.
Good.
Oh, I remember this.
So we put pi over 2 out here,
And then you would do half of that.
which is?
Pi over 4.
Good. And then?
Half of that is pi over 8.
Very good.
And then 3 pi over 8 goes within 2.
Very good.
Yeah.
Yeah, you guys did really well at this.
I got a perfect on this quiz.
You guys all did really well on these things. All we had to do, it just took a little bit of practice to get used to it, and once you got used to it, it was easy. Okay? Now, it's just a matter of marking off our a values. Our a value is 3, so it's going to go up 3 and down 3. This is a sine graph, so we already said that sine always starts at, for a parent, starts at 0. This time, a is positive, so it goes to the maximum, 0, minimum, 0. And we would just do this.
I thought we
It is
Oh,
a
never
parent.
mind. Oh, dang, I knew that. Okay. Never mind.
Now, when we did that, we draw our parent, and then the next step would be to shift everything. So the shift here is just to move everything down 2 spots. So I move this down 2. And we get this curve. Are we okay with that?
Yes.
All right, so let's do this. I want to just look at the shift now. Obviously, you guys all have it on your regular graphs and all that. It's not a big deal. But I want you guys to see what happens when you have a regular shift. One thing you should notice is that you have a maximum and a minimum value. You agree? Now, how far apart are these two? 6. There's 6 units apart. We also know that a sine or a cosine graph, they're equal above and below.
Yeah.
So your overall distance between the maximum and minimum, if you cut it in half, what is that going to give you? A. If you take your maximum value here, which is something comma 1, your minimum value here is something comma -5, the distance between them, the absolute value, is 6. Right. So the distance between your max and min over 2 is A. Now, it's up to you to decide, is that A value can be positive or negative. And it's pretty easy to tell if you remember what way sines and cosines go. Remember that a sine graph will start and repeat that spot 3 times. Whereas a cosine starts at a maximum or a minimum, and it does not repeat that spot 3 times. You see that? Probably something you never picked up on before. Your y value is repeated in a sine 3 times through the period. Okay? That's kind of an easy way of doing that. Now, the other thing I want to show you here is not knowing what your period is. If you look at the distance between here and here, how far apart was pi over 8 to 3 pi over 8? Pi over 2. The distance between those two was pi over 2.
So the distance is like horizontally between your maximum and your minimum are
Oh, sorry. The whole thing. Pi over 4. 3 pi over 8 minus pi over 8 is 2 pi over 8, so it's pi over 4. Excuse me. Okay.
Yeah.
So the distance between your maximum and minimum,
times 2.
double it, and it's your period. The distance between, the horizontal distance between double is your period. So in this case, the horizontal distance between the maximum and the minimum was pi over 4. You okay with that? So this one here, I take pi over 4 and I double it and I get pi over 2. Now think about period. How do you find the period of either sine or cosine? So if my period is pi over 2, has to equal 2 pi over b. What is b? 4. So you're able to deconstruct
So
from
it's
the
working
graph.
backwards from what we already have done.
That's all it is.
Seriously?
That's all it is. We're working backwards from 2 ordered pairs, basically. You're going to see a maximum and a minimum. Looking at how the graph is replicated through, you're going to be able to identify whether it's sine or cosine, and then pluck out your A, B, H, and K. Now, I know that you can do horizontal and vertical shifts and everything like that. A sine graph is just a horizontally shifted cosine graph. And a cosine graph is just a horizontally shifted sine graph. We're going to keep it simple and not throw H at you. All right? Because there's no way of knowing whether it's going to be sine or cosine if you throw an H in there.
Well, what about that whole like 3-point thing? Yeah, okay.
See how it goes? Because if you go back down to it and just think about what the unit circle was doing.
Unit circle.
Oh, quit your whining.
Bringing it back.
Well, last time.
Sine went 0, 1, 0, negative 1, 0.
Right.
Cosine started at 1, 0, negative 1, 0,
1.
1. Which is just the sine curve.
Go one by one.
Oh, make this look cool. It's going to group everything. I want to group everything.
Is the right. But she like just connect the line. Yeah, there you go. What the heck?
You can't because we didn't do this like a bunch of times.
Which is basically a shifted sine graph.
Whoa.
If I would have continued on here.
Oh, so that's why you can't do H.
Right. There's no, I mean, because which one is it? Is it sine or cosine? If you shift the cosine graph left, what would it have to be? Or if you shift it to the right, pi over 2, isn't it a sine graph then?
Yeah. So we'll never have to go through this. Okay.
There's really no way of knowing. All right, so you can kind of not worry about an H. But you can still worry about K's. It's pretty easy to see how it goes. Let me show you an example.
I'm excited.
Sinusoid is just either a sine or a cosine graph. It has a it has no asymptote to it. It's non-asymptotic. I think I just made that word up, but it sounded cool. It has the how do you want to say it? I don't want to.
Wait, have you seen the cosine?
Well, let's take a look at it.
Give us a second.
In this case here, and we're looking at the origin here. There's no H shift. Your difference between your lower end and your high end is how much? 8. So your overall height value, your vertical part.
Wait, do you want us to graph this as a salary one?
Yeah, because we're not doing any parent function here. We're going to pull out everything that we need just from this.
Wait, so this is like already like, even though this isn't really like, well, actually, yeah, I was gonna say this is, but it is.
Now this means that, what is your amplitude? What's your A value?
4.
Your A value here is going to be 4. Now you have to decide, is it going to be a positive or a negative 4? Why? Good. Notice how it starts at its minimum value. When it starts at the minimum value, that means it's cosine, and since it started at the minimum value, it's negative, so your A value is negative. We also know that it's cosine because it starts at the minimum. Cosine starts at a maximum or a minimum. Sine starts at 0, or whatever value's been replicated. Now take a look.
So would you say like -4? Or you can make here for the.
Yeah, I'm sorry, I know that this is going to be a cosine, I just leave it there. I know it's going to be a cosine. We're going to figure out what B is. So we look at the distance between maximum and minimum. This distance is pi over 3,
Yeah.
which means what do I do to that?
It's
Pi over 6.
2 pi over.
Times 2 is pi over
Oh,
2.
you're
Pi
right.
over 3. 2 pi over 3.
Divided by 3, or divided by 2.
2 pi over 3, so that's your
So
2.
2
So
pi
that
over
means B is 3.
Perfect. So that means that my period here is 2 pi over 3. So I set that equal to 2 pi over B,
So
which
B is
means
3.
B is
I probably wrote
3.
this down.
A very easy thing to notice is that your maximum and your minimum values are the same, which means that the distance between your origin, your maximum, your origin, and your minimum is the same, which means that there was no there's no vertical shift to it. If there was a vertical shift to it, these two numbers would be different. Does that make sense? That meant that there's a different center line. It's given you the midpoint of these two values is 0.
So here should be like 6 and
Then it would be at what? If it was up at 6 and -2, that's how far apart. So you mean your vertical would be +2.
So it's just like as a.
Does that make sense? That way they're balanced the same amount. You're finding the midpoint. Yeah. So your B value is 3. We have no K value because there's no vertical. We're not worried about horizontal shiftiness here. So my answer winds up being y equals -4 cosine 3.
How do you know there's no K? Because they can't have that K.
Oh, yeah.
Your midpoint here.
Oh, yeah, never mind. But it goes into 0.
Yeah.
Wait, are the equations the same for sine and cosine except like the sine and cosine?
Yes. Yes, they are the same. All right.
Wait, so.
What?
After every email. Yeah, she always says that. Whenever we do anything involving like algebra, you know, like plugging in correct, she's like, you do your math and you get your answer. She says that every time.
Do you have a board going for her?
There aren't any open boards in there.
Yeah,
We'll
let's
start
you're lucky.
filling, we'll make chemicals.
You want to borrow a whiteboard, little mini board?
Start filling in
And just
with, like,
hold it up and like every time.
That'd be funny.
Yeah.
But I don't know her very well. Would she get the sarcasm?
She thinks I'm funny, so.
You're funny looking, but that's besides the point. Sorry.
What? How do you know that? That's not true. She told my parents that she really enjoyed coming to class.
That's just one thing that teachers should say.
Thanks, guys. Make me feel great.
Hey, if we didn't do it,
All those middle
you'd have to
school
walk
teachers-
your head out the door sideways.
Those middle school teachers, they have those pre-assigned compliments that they put on.
Oh, okay.
Unless you're driving class, I got those all the time.
I did not. Actually, I did always get pleasure to have in class, but they always like really kind. And I always went to my conferences so I can see the sincerity in their eyes. Didn't go this year because I was tired.
Because I was tired.
All right, let's take a look at this. We have our two ordered pairs. Notice that the graph starts at the origin, goes up, past the origin, goes down,
Or wait.
past the origin, and back up. How many times did it touch where it started?
3.
So is this going to be sine or
That's a
cosine?
really straight line.
It's got to be a sine
Man, that
graph.
really
This
messes
has to
me
be a
up.
sine graph. Okay?
You said
It's easy to tell because we're looking at the page.
You want it to be a cosine because you see the 2 points, you're thinking it's shifted. It's not. Remember, go easy on it and just go right off the sine value.
Wait, it's not.
Shifted, he's thinking shifted horizontal. We have no h values here.
No H.
So in this case, our a value is going to be the distance between our two.
This is hard to. 10, like,
Yeah, I agree.
Now, your a value is what?
10.
10. Everybody okay with that?
Wait,
Yes, because it's 20. Yeah.
Yeah.
The distance between 5 and negative 15 is 20.
Yep.
Half of it is 10.
Yes.
Now, will it be a positive 10 or a negative 10? It's positive because it went up first.
Oh, here it is. I was thinking it was going to put started, but that's what it was.
Our b value. Take a look at how long it takes to repeat. Half between 1/2 and 1.5 is how far?
1.
That's 1. You double it and you get 2. So our period is 2, so that has to equal 2 pi over b.
So B is pi.
What?
Yeah.
B equals pi.
So b,
Wait, period is 2, so
B.
that's weird.
your b value is pi. Now, take a look at what happened to the origin. We know that the sine graph would start at 0 and it went down how many? 5. So what's your k value?
Negative 5.
Very good. Put it all together.
Wow.
Sine graph.
Equals 10 sine pi x minus 5.
Not in parentheses. This might be this is a good candidate of putting the negative 5 plus 10 sine 5. This would be a good candidate to do that. Because you guys might have a tendency to want to throw a parenthesis around it, because that's normally what we would want to have. Okay. What do you got? What else do you got? Why is it negative 5?
Wow.
Normally the sine graph would start at 0, 0. Do you agree? Where did this one start at? Yes, sir.
Why is B pi?
The distance between 0.5 and 1.5 is 1. I double that. So my period was 2. The period has to equal 2 pi over b. If I solve this, if I solve this the long way, I get 2b equals 2 pi. That's all. What clarity did she saw that, if I divide that by pi, it gets 2. That's all. All right? I understand, though. Yeah. Just look at it.
You just did the face.
What page?
She will show this.
All right.
Obviously, I can do more.
Next one here.
Wait, does it go first?
First thing I'm going to figure out,
Negative 1.
I'm going to look at the difference. Remember the difference between the maximum and minimum horizontally,
Careful.
and help me figure out my period. So pi over 2 minus pi over 6 would be, because this is 3 pi over 6, so it would be 2 pi over 6, which is pi over 3, which means the distance here is pi over 3. So my period would be 2 pi over 3.
So B equals 3.
And then, so that has to equal b, so b is 3. That's pretty easy.
Wait,
Okay.
hold on. I have to watch this.
I found the distance between the maximum and the minimum. The distance between those was pi over 3.
Double that?
Double that gives me my period.
Oh.
All right. So now the distance between the two heights vertically, it's the same. It goes up 1 and it goes down 1, which means
3, 4, 2.
1.
No, it's 2.
Your A value is 1. It goes up 1, it goes down 1.
Oh, you're right.
This is a sine graph, and it starts at the origin.
Before you divide by 2.
Okay, now I see what you're saying, yes. It started at the origin, it went to the minimum, origin, maximum, origin. So it's sine with a positive or negative a.
Negative.
Negative, so a is a negative one. So it's y equals -1 sine 3x.
Like on side.
There is no vertical shift here because 0 is replicated 3 times for a sine graph. Okay?
You're right.
The second one, yes, it's a little bit dirtier. What I want you to see, you start your graph at a maximum. What graphs start at their maximum? Cosine. So this has to be a cosine graph.
Oh, and it's -1.
It starts at its maximum, so it's got to be cosine. Yes, sir?
You had
It doesn't go up or down.
Is it okay if you just write negative sign here?
Yeah, that's fine. Then it goes past the origin, down to the origin, and back up. So now I know that my origin here has to be at
-2.
-2. So we know that there's a vertical shift of down 2.
You're right.
Your original origin would be at 0.
So it's 1. It's 0.
Your A value is still 1. The reason that it's 1, because the distance between your maximum and minimum,
Divided by 2.
Divided
I
by
didn't do
2
that.
1.
correct. Because you are replicated the same distance between the origin that's repeated above and below. This is 1 apart, this is 1 apart. Since the cosine graph started at its maximum, the A value is still positive. The distance between where the maximum and the minimum occurred is 1,
Divide that, or times that by 2, that's 2.
and that gives you your period. So I know that my period is 2, which has to equal 2 pi.
Yeah. B, so B is pi again.
Oh, wait, here it is.
You have to put the origin in there.
Horizontal distance is 2.
Take the distance between,
Your horizontal distance is 1 times
take the
2.
distance between the maximum and the minimum.
You're looking at vertical.
I got it.
The distance between your maximum and your minimum is 1. You double it, and that gives you your full period for that problem. Set it equal to 2 pi over b to figure out b, and now you're done. You've got your A, B, and K. So your answer is y equals, what is it, cosine, or it's just A, so it's cosine
Yeah, it is
of
close.
pi
I knew it was close.
x. Well, let's put the negative, oh, that's why you're saying -2.
Yeah.
-2 plus cosine pi
It
x.
starts at 1, so it has to be.
Yeah.
Well, it starts
Oh,
at
shit,
1.
you
You
can't
can't
get
check
on
it.
Now, remember, it's cosine because it started at its maximum,
Yeah.
and it could be a cosine because if it starts at its minimum.
Wait, isn't A,
And A is positive because it started at a maximum.
wait, A is,
I get it
Right.
now.
wait, A is positive and goes down?
Yes. Remember, think about a regular cosine graph. Cosine starts at 1,
Yeah.
0, -1,
Oh, so
0,
when it's- so
1.
like when it's sine, how does it goes down?
Then it goes down.
Sine is negative.
Right.
Okay.
Why is that the hardest part?
Okay.
Everything else is easy except for you just gotta tell it sine and cosine.
Right. And that it comes with a little bit of practice by looking at the graph. If your symmetrical part, the horizontal symmetricity, is that what it is? I don't know. Whatever.
Symmetry?
But it's not horizontal symmetry. Yeah, it is that.
Yeah.
Thank you. I am not an English major. I think you've noticed that before. I spelled chunk wrong earlier
Oh,
today.
I was wondering.
You put a C in it?
Did you put -2 or negative?
Oh,
So
no,
if
wait,
it is
it's a raise.
symmetrical, that it's cosine, but if it's not, and it's an image, then it's.
Just remember, sine has a origin replicated 3 times.
Did you put -2 or negative?
That's the easiest one. Okay.
I'm trying to remember what we started with.
I want you to do some problems here.
Try a few of them.
Why did you guys try these last night?
Wait, we started with,
Say something.
Did we really start with correlations and best fitting lines?
Do these for me.
Yes. We've done a lot of weird problems in this unit.
The word problems? No, that was different.
That was still this one.
So we've done 2.5.
We did 2.5, 3.4, 5.7, 6.9, 8.7, 8.8, 14.5.
5.8. We got 5.8.
5.8, and a partridge in a pear tree.
How about all the problems?
You were totally off key when you started that.
Of course.
Just 10 through 15, that's it?
Yep,
That's it?
yep.
Yeah, they take a little bit of time.
They take a little bit of time to get used to it. Yeah, once you do those.
How many problems is 10 to 15?
That's 6 problems.
So I want. It's like you and I get along. What I want you guys to see here is that tomorrow we'll look at what these things look like. Tomorrow we'll look at these things when they're in table form, as well as just ordered pairs. I'll give you an A value, like a maximum or minimum, or just 2 ordered pairs. You have to decide, is it a maximum or minimum, and bail you out of it. So
That'll be exciting.
that's a little bit too much to do in one day. Well, and then we'll try and tie as much of this together before we test out on Friday. But who knows? Maybe we'll do it Tuesday. I don't know. Right now, it still looks like we can go Friday, but depends how much we get through this strong.
Why not Monday?
You don't want a Monday test.
Why would you recommend that? I have a question. Are you gonna give us like a review sheet with like all the sections on it? Or are you just gonna give us some problems out of the book?
Have problems on the book because there's so few of these problems. You know?
Just trying to get all of our homework back.
Yeah, I'll get it all back. All right, and that's, I mean, it's really all it is. And I want to spend a little bit of time tomorrow just to kind of remind you guys how you tell where certain things are. It's not, when you're working a lot of these things, we know how to tell if something's linear via a table. The differences in y's automatically are all the same. If it goes up by 2s, it's very easy to see. If it's quadratic in a table form, you did this finite differences. The second order was all the same. It was cubic, the third order. It was quartic, the fourth order. Those were all the same.
So we don't need calculator.
When you did the exponential ones, it was exponential was because it was always an increasing rate. The slopes between the 2 points was getting greater and greater and greater every single time. If you looked at it graphically, it looked like it was a scoop moving upward. And then you were able to tell whether or not it was, in fact, exponential by taking the natural log of the y value to show that that was linear. When you're doing stuff like that on a test, you just write down a second table of natural log values, and then you said showed linear, this is why it's an exponential function. Okay? We did the logistic ones. The logistic ones looked like they were a cubic function, but they had a ceiling, and they had a floor. And they mainly dealt with population. Because you can't you can't have negative people, and you're going to have a cap at which no longer sustain life. You run out of oxygen. Because you're cutting down all the trees.
Actually, I just read some biology.
For
It says
needs.
that phytoplankton make up for like 50%.
We need to conserve our oceans, not our trees.
Those two.
Yeah, saving the oceans.
It's Earth Day.
50%. Yeah, it is.